Hey everyone, welcome back to part 2 of this two-part tutorial for creating and deploying an image or file uploading API pipeline using Amazon S3, API Gateway, and AWS Lambda. In this part, we'll be setting up the API and writing up the Lambda function that helps process and upload the files to our S3 bucket. So without further ado, let's get started. Now, the first thing that we're going to do here is actually set up the serverless.yaml file for the Lambda function and the API event trigger. So if you recall from my other videos, that one of the great advantages of creating serverless applications and using serverless functions is that you can set up triggers. And one of the triggers that we can use is having an API call as the trigger. So for example, if you make an API request, it will trigger a Lambda function and then we can process that. And the idea here is that we will be uploading an image through our API and we'll be using a post endpoint here. And afterwards, our Lambda function will process the image and upload it to our S3 bucket. So let's get right into this. First things we want to do is use the functions field in the serverless framework. So functions, and we're going to declare a function here. So I'm just going to go ahead and call this the S3 file uploader. Feel free to be creative with the naming here. And of course, we'll need to specify where our handler is stored. I haven't created it yet, but I'm going to put it under the source folder. That's just the convention I prefer to follow. And I'm going to call my file name upload.js later, and my function name will also be called handler. It will make a bit more sense when we actually write the function in the latter part of this video. Anyway, we will also specify a name for this function. Again, S3 file uploader. Again, this name here is just for the serverless framework to know. This name here is the actual name of the Lambda function that will appear in AWS, and we'll see that in a second. And we'll also want to include a quick description, so we'll just say this is a Lambda handler that uploads a file to an S3 bucket based on an API gateway trigger. All right, awesome. Okay, and of course we want to specify things like a timeout, and of course this will be in seconds. I'll just make a quick note here. And we also want to specify the memory size. Since this is just, we're not doing too much processing here for the image, we probably won't need much memory. So I'll just keep it as 128, which is the minimum. And this is also in megabytes, so we'll leave it as that. And the next thing that we want to do is actually specify the event trigger. And to do so, we have this field called events. And after that, we can actually specify the HTTP event trigger, which is what we'll be using. So to do that, we'll just do -HTTP colon and with some indents. And we're going to specify the actual path of the endpoint. So I'm going to go ahead and just call this images. You can feel free to name this whatever you want, maybe like images/upload, or maybe if your resource is like files in general, it'll be like file/upload. I'm not sure. But yeah, just feel free to name it whatever you want. In this tutorial, we'll just call it images. And after that, we also need to specify the method or endpoint type. And in this case, it would just be a post endpoint. So as you probably noticed, this is actually all that we need to set up the API trigger for our Lambda function. So thanks to the serverless framework, a lot of the cloud configuration stuff is already masked for you behind this. So it doesn't require many lines of code, which is awesome. And that's pretty much it for setting up the trigger for the Lambda function. Now we can go ahead and move on to granting granular level of permissions for our Lambda function. So in this case, we only really need our Lambda function to access S3 in the case of adding things to the S3 bucket. So we don't want our Lambda function to perhaps maybe like delete things from the S3 bucket, or maybe even read from the S3 bucket, because we don't need that for a Lambda function. Maybe you want to create a Lambda function later on for maybe to extend this project to perform delete operations or read operations. We can cover that in another tutorial, but for this Lambda function, we want to limit the permissions as much as possible, and this is definitely a best practice. And one of the fields that the serverless framework offers us is the field called IAM role statements. And by default, this field is a global field under the provider section, which is a little bit unfortunate because this applies to the entire project, and every Lambda function within it will follow this IAM role statement section. And the reason why I say it's a bit unfortunate is because sometimes you want to have more granular level of permissions per per Lambda function, but by default, the serverless framework does not support that. Fortunately, thanks to open source projects and whatnot, someone has created a serverless plugin for the serverless framework that we can use. So we're going to go ahead and actually quickly import that right now. But before import it, actually, we need to install it, and we can actually install this as a development dependency. So we're going to go ahead and type yarn add -d, and I believe it's called serverless -im role im roles per function. I hope I've typed that correctly. Uh, yes, I have. All right, and it already installed package.json, and I believe I haven't specified git ignore, so I'm going to go ahead and do that because we ultimately don't want to push our node modules. So I'm going to quickly do that. All right. Okay, that should have changed. Yes, okay, awesome. All right, and that's pretty much it for installing the dependency. And we actually need to import it explicitly in the serverless framework. And one way we can do that is by using the plugins field. And we're just going to go ahead and list it. It's called serverless IAM roles. I can never get that right. Serverless IAM roles per function. So now that we've had specified that, when the serverless framework runs the configuration file, it will automatically import this, and we can actually use the IAM roles role statements field inside every single Lambda function. In this tutorial, we only have one, but if you want to extend this project further to have like delete operations as mentioned earlier, this will become very, very helpful, and it's often considered a good practice. So we'll keep it like that, IAM role statements. And now we can move on to writing the actual IAM role statement. And this follows a general syntax as CloudFormation as well. So we can go ahead and actually write -effect, and the effect that we want to perform is to allow. And what do we want to allow? We want to allow the action of our Lambda function to be able to actually put things into our S3 bucket. And there is a full list of I role operations that we can allow for every single AWS resource available. And they often all follow this really similar syntax. So the resource goes first, and then there's a colon, and then the operation comes after. So I believe the main operation we need is put object as so, but we can actually use a wildcard here to allow us to access any operations starting with a put prefix. So we'll leave it like that. This is already fairly granular because our Lambda function cannot delete or read anything else in the S3 bucket. So we'll leave it like that. And lastly, for the IAM role statement, we also need to specify the resource that we want our Lambda function to have access to. In this case, it will only be our S3 bucket and no other S3 bucket on our AWS account. And to do so, we need to specify the ARN, or in other words, the Amazon resource name. So we're going to specify it as in this format, which is the general format for S3 ARNs. So it goes like ARN colon, AWS colon, S3 triple colon. And then here we're going to use the variable that we have created last time, the custom variable here. So this has once again become very useful. And we're just going to reference it like this to get our bucket name. And one small thing that we want to note here is that we actually want our S3 bucket to have permissions to, for example, write or put objects inside any nested folder or directory inside our S3 bucket. So to do so, we'll just add another wildcard character, so /star, meaning that the Lambda function can have access to put objects inside any nested directory. And yeah, this is pretty much it for the IAM role statement that we need for this Lambda function. And we can go ahead and finish up by just writing up or assigning an environment variable for our Lambda function. And this environment variable will just hold the bucket name. So file upload bucket name. And once again, the variable becomes useful, the custom variable, as we can store our bucket name here. And awesome. So the reason why it's just a personal convention, but it'll be easier for us when we actually try to reference the bucket name. It's just so that we only have one place where we declare the bucket name, and we don't have to modify multiple places, for example, in our code or our configuration file in case we ever make changes to the bucket name. But yeah, feel free to follow a different convention if you prefer. Anyways, that is pretty much it in terms of setting up the configuration file for the serverless configuration file for the Lambda function, as well as the API trigger and the granular level of permissions. And now we can go ahead and actually create our Lambda function. So to get started, we're going to go ahead and create our Lambda function inside the source folder, and we're going to create a file called upload.js. And first things first is that we want to import the AWS SDK dependency. We'll install that in a second, but it'll just be called AWS-SDK, and awesome. And we're going to go ahead and quickly install that right now. So, and this needs to be a production dependency, so we'll just do yarn add AWS SDK, and this will take a moment. It's a fairly larger dependency. Okay, awesome. So once that's done, we want to initialize the S3 object so we have access to S3 functions in the AWS SDK. And to do so, we can do const S3 equals new AWS.S3. And after that, after we've initialized the object, we can actually also retrieve our bucket name from the environment variable that we have specified in the serverless framework. I'm just going to call this bucket underscore name. Since this is going to be a constant, and with Node, we just access, we can access environment variables like so process.m dot file upload bucket name semicolon. Okay, awesome. And we're just going to set up the framework for our Lambda handler. And if you recall from earlier part, we've actually named this function handler, so we'll follow that. And this needs to be an asynchronous function, so we'll keep it like that. All right. Okay, and it's exported. All right, awesome. And so first things first, just might be a good practice, especially if you're debugging, is to just log the event so you can see what you're working with. And this will be an API gateway triggered event. So we'll leave that. And now the way I like to do this is just to create a response object first off, right off the bat. And we can modify this depending on what response code we want to return. So in this tutorial, we'll actually be using a Lambda proxy integration, and please do make note that this is different from a Lambda integration. There will be another video covering the difference between the two, but there's a specific syntax that we need to follow for Lambda proxy integrations. And first feel is that this isn't necessary, but the first thing we want to do is first specify that whether the response is base64 encoded. In this case, it will not be. One of the required fields is actually the status code. So by default, we'll just return 200. And one important detail that a lot of people actually miss out on is that it needs to return a stringified JSON body. It has to be stringified. If it is not stringified, when you make a request to this endpoint, your Lambda by default will return a 502 error, I believe. So definitely be careful about this. So yeah, anyway, just make sure it's stringified. And so I'm just going to include a default message saying like successfully uploaded file to S3. Ooh, okay. All right. The braces, oops, comma. There we go. Okay. And then, of course, I like to follow the convention of having a try catch statement just in case our upload somehow throws an error for some reason, or a parsing error or whatnot. And we're going to go ahead inside the try block. We're going to go ahead and parse this event body. So in this tutorial, we are actually going to use a base64 image file. You can also use base64 for a PDF. There are definitely trade-offs with using base64, but for the sake of keeping things simple, we'll just use that for now. And we're actually going to go ahead and decode this file so that we can actually upload it as an image. So I'm going to be calling this, I'm going to be referencing this image base64 value under the file field of the event body. So I'm going to call that file, and we're going to actually decode this file now by reading it from using a buffer. So base60, oops, forgot the bracket, base64 file dot replace. And the reason why I'm using this replace here and actually have this regex pre-configured is because so oftentimes your base64 image will have this regex in front of it, and I'm just going to use this replace to remove it because we don't need it. And yeah, you can feel free to modify this as well. For example, if you're using a PDF or other type of file. But yeah, we'll leave it like that. And of course, to specify the buffer, we'll specify that it's reading from base64. Awesome. Okay. And I'll also create a variable called params, and this will store the uploading parameters for when we actually want to upload to the S3 bucket. And one thing that we want to include is, of course, the bucket name. So we'll type that. And we also want to write the key. And now the key represents both the directory as well as the file name that we want to upload this file into. So we're going to go ahead and actually demonstrate that we can create directories when we upload this first file. So and what I mean by that is we're going to actually create this file, directory called images, just so that we can have better organization in our S3 bucket. So images slash, and then I'm just gonna use the current date time using UTC format as a string, and I'm just going to convert them all to JPEG. Of course, in a real case scenario, you would actually want to get the real format of the file and use that. But I'm just going to use JPEG here for the sake of simplicity. And of course, the body of the file will be the actual image that is decoded. So we're going to use the decoded file variable here as our body. And last thing we want to do is just include the content type. And in this case, once again, it would be image/JPEG. Awesome. So that's the parameters we want to upload. And the last step is actually really simple. This is the step where we actually perform the uploading, and we can just call the SDK function, which would be S3 the upload, and we pass in the parameters, and we need to take the promise because we are awaiting on it. And we have to await on it in Node.js so that we can actually get a response back. Otherwise, our Lambda will perform it will just perform oddly, and it's likely that our Lambda will finish before we actually upload it, and it'll end up being that our file never gets uploaded. But yeah, so yeah, make sure we type the await. And lastly, we just want to include perhaps the upload result in our response body in case we want to see the result of the upload. So we'll just do that. The message here, I guess it would be the same. So I'm just going to copy that real quick. And one thing I want to include is the upload result. All right. Okay, awesome. And that's pretty much it for the try block, so the happy case. Yeah, and now we can just go ahead and do some simple error handling. For example, if there's an error, we're just going to log the error. You can decide on a format for the log for yourself. And the response body, of course, this is the endpoint response. Again, it needs to be stringified. We're going to just write a quick message saying file failed to upload, and we're going to include the error message or the stack trace of why it failed. And awesome. And of course, if our for example, if our Lambda function failed to upload for some reason, we probably want to include maybe like a 500 error. So we'll leave it like that. And last thing we want to do is, of course, return the response, and that is actually pretty much it. So this pretty much wraps up the code for the Lambda function. So once again, just to summarize, what we've done here is we set up the response variable for the endpoint, and for the Lambda proxy integration, which is what we're using here, we need to make sure that the body is a stringified JSON object. And in the try block here, we're actually parsing the event body and make sure it has to be parsed. And we're referencing the file field in the event body. And then after that, we are reading it as a base64 file. In this case, it'll just be an image. And then we are configuring the parameters for the uploading operation, which includes the bucket name, the formatted key field, which is the name of the object that we will be uploading, and the body would be the decoded file itself, which would be the image once it's been decoded, and then we perform the upload, and then we specify the message for the response body, and then we do some error handling. So as you can see, it's actually not too much code to perform this upload. Now we're going to go ahead and deploy this function to AWS, and we'll be back to demonstrate how we can actually test this endpoint. So now we're back, and as you can see, we have deployed our Lambda function successfully, and it's here. And if we actually go ahead and head over to API Gateway, we can also see our API Gateway set up here, dev S3 file uploader. If we click into it and head over to the stages on the left side menu, and we click into dev, which is our environment, and hit post, we can actually see the URL at which we can invoke our endpoint. And so we're going to copy this, and I'm going to use Postman in this tutorial. It's just the client, API client I prefer to use. And we're going to paste that in here with the full URL. And we're going to select post and select an application JSON type as the content type. And I've actually already pre-configured a request payload for the body under the file field. And this is just the base64 string of an image that I had at the moment. And so we're going to go ahead and actually click test or send. We're going to send it. It might take a while. It took a few seconds, 1 second actually, and we finally get the response code of 200. And as you can see here in the response body, we also get what we have specified, which is the message and the upload result. And this tells us the bucket that was uploaded into, as well as the key or the path at which this image is stored in the bucket. So now we can head over to S3, and if we check our S3 bucket, we can see that it created an images folder. So if we click into that, we can also see that it has uploaded our image. And there's 2 images right now. It's just because I tested earlier to make sure that it worked. So yeah, but our most recently uploaded image would be this one, according based on the timestamp. And if we actually want to view this image, we have two options. One of it, which is just to download the image. So we can just check this one and hit download as, and we can click that. Uh, and once we open it, as you can see, the full image is produced. And this is just a thumbnail from one of my previous YouTube videos. And yeah, the other option is to actually click into the image, and we're going to go into the permissions tab, and we're going to modify the access control list. And because we have already pre-configured the entire bucket to follow an access control policy of public read, it means that we can read things in the bucket. But for each individual object, we also need to modify the ACL, and we'll just check read access for everyone to have public access, and we'll acknowledge that this is a security breach basically, and then we're going to go ahead and click Save Changes. And once that's done, we can head over back to Postman and copy this URL that the API has generated for us, and if we search for this, we can see that effectively S3 is serving this image as a CD through its CDN, and we can view it online as well. But obviously, again, this would be maybe not the ideal way to serve images, especially since it's public now and anybody can access it. So if you are holding private content, definitely you would need to implement better security policies for your bucket as well. But anyway, that pretty much wraps up this tutorial, this two-part tutorial for creating an API for uploading images or files in general to S3. And of course, if you learned something or found this video helpful, please do consider hitting that like and subscribe button down below, as it really helps out the channel and series. And if you have other content or tutorials that you'd like to see, feel free to leave comments below as well. And as always, I hope you're all staying happy, well, and well out there. But for now, I'll see you in the next video.